I'm doing a little demonstration of two different hydrogen gas machines, and I'm going to be pumping the hydrogen gas through these cannula tubes right into the water. Now, I'm just going to turn, oops, I had it on. Oops, I got to push that button. I'm going to turn the machines on, and then there's probably going to take a minute or two to start pumping the hydrogen gas through these tubes. It's just a certain amount of pressure needs to be built up. In the meantime, okay, so the one on the left, the BioBase machine, seems to be pushing it out already. Alright, they're both bubbling. One's bubbling a little faster than the other. But, okay. So now I'm just going to start measuring the hydrogen levels. Right now it just is coming up pretty close to 0 in both. I'm just going to flip between the two as we go. Alright, this one's starting to climb a little bit. Let's see if this one is also. Yeah, okay. So now they're both starting to climb a little bit. This one's up to, like, varying a little bit. 59, 40, 43, 58. Let's see if this one's varying. 21, 25, 29, 30. This one's starting to climb. This one's still varying. Okay, this one is also varying. Okay, so until the water levels in the water are starting to get saturated, it's going to be pretty much varying. So we're up around the level of 0.7-ish. And over here on the right, we're about 0.6. Or 0.7 now. Seems like they're just a few seconds off of each other. Now, obviously, if you had the water in bottles, stainless steel vacuum sealed bottles, and we're not letting so much of the hydrogen just escape into the air above these things, it would probably saturate faster. And this one's above 1 now. Now, above 1 is really what I would expect from a water ionizer. 1 part per million of molecular hydrogen is definitely well within the medical range of molecular hydrogen saturated water. And this is also hovering around 1, almost up to 1. Went over 1 for a second there. And normally you wouldn't use a hydrogen gas machine to pump hydrogen into the water. You'd usually just get a hydrogen water generator, such as the Ion Pia, which is to the right of all this. But I'm just testing the two machines' ability to put out hydrogen gas. And to do that, prior to this, I was just testing the gas right out of the cannula. And that was mostly escaping right into the air, so it was very difficult to compare the two machines. So here, this one's up to 1.2 parts per million. And this one is up to 1.09. So they're kind of neck and neck here. Now, I have done testing of this before, and after 5 minutes, the BioBase machine, which is on the left, was up to 1.01 parts per million, and the SPE270, which is on the right, was up to 1.27 parts per million. And that's after 5 minutes. After 10 minutes, they were pretty much equal with each other at about 1.35 parts per million. Now, I think it reached 1.35 parts per million after 7 minutes. And I'm sorry if this is boring you, because I realize it's just a lot of talk. But after, 7 minutes, 3 minutes later, it was still at 1.35, so I just quit testing. Now, I think that really to saturate the water higher than 1.35, you'd have to have a sealed, a rather sealed container. Like have a lid on your container or something. This is just so out in the open. So this is almost up to 1.35 now. It's at 1.3. I saw it kind of was hovering around 1.3. And this one's kind of hovering around 1.10. Or 1.1, I mean. 1.15. So they're similar machines. The one on the left is maybe something more that you would see in a hospital room or a clinic or a doctor's office, that type of thing. Now, the one on the right kind of blends in with furniture a little better. I would think this is a better one for home use. It also is a little tiny bit stronger. The one on the right, the SPE270, flow rate is, as you can see, it's got the flow rate here, 2.67, or 267, excuse me. Parts per million per minute or whatever. I'm not sure exactly, but it's a high flow rate. The one on the left, the BioBase, is 200 flow rate. H2 air flow. Oh, milliliters per minute is what it is. Sorry. So between 200 and 270-ish, it's a little bit more powerful, the one on the right. However, like I said, I mean, it's going to get a certain amount of saturation, and then the water is not going to go any further. Now, this has been hovering around 1.3 parts per million for a pretty long time. So I'm about ready to quit this video testing, I think. If it doesn't change significantly in the next minute, we'll just call it. So it's like 1.33, 1.32, 1.30. It's kind of fluctuating around that. This one's about 1.15, 1.16. So all right, well, I'm just getting ready to call this thing. It's not really changing a whole lot at this point, so that's pretty much the numbers. Okay, both really great machines. If you can possibly afford to get a hydrogen gas machine, they're very versatile. Let me just keep on showing this one if I'm going to talk. I have used this. I had a toenail that just didn't want to grow back. I had cured the toe fungus. I had dropped a barbell on my toe, and it was just a toe tragedy. Well, there it's up to 1.35, but after a few years, it's just not. I cured the fungus, but it just wasn't growing, and I've been soaking it in hydrogen water that had vinegar in it. You can't put that water into a machine. It will destroy the machine. So I just dropped one of these cannula hoses into the bowl of water, and it was just pumping molecular hydrogen in there. And I could really feel my toe feeling better, and it looks like the nail is growing better. I mean, it's like a fraction. It's hard, you know. I'm not going to post pictures of my toe, I'm sorry. But it does appear to be better. So there's that and some other things that are really good use, I think, personally, of the hydrogen gas machine. Plus, it's just kind of nice, you know, kind of relaxing to breathe it in and gives you extra hydrogen. Okay? All right, thanks. Bye.